Here is another example. The following table shows a probability distribution of a discrete random variable. Find the value of m. To find the value of m, we know that the sum of the probability in a probability distribution is equal to 1. That means if we add 0.4 plus m plus 3m, you're going to get 1. So here is an equation that has m. We need to solve for m. That will turn into 0.4 plus 4m is equal to 1. Now we want to solve for m, so we're going to subtract 0.4 from both sides of the equation, and that will lead to 4m is equal to 1 minus 0.4, which will give me 4m is equal to 0.6. And then I divide both sides of the equation by 4. I'm going to get m equals 0.6 divided by 4. So I'm going to compute it here. This is equal to 0.6 divided by 4. So the answer is going to be 0.15, meaning that this cell, which is m, is going to be equal to 0.15. The second cell is going to be 3 times that, so this is equal to 3 times 0.15. It will give me 0.45. Now that I have this table here, I am going to figure the expected value in the next question. The expected value or the mean has a formula, and the formula says the mean is the sum of x times p of x, meaning we need to find all of the values of x times p of x and add that answer. So I'm going to create another table that says x and p of x here, and I have the first x is 2, 4, 6, and I have the probabilities 0.4, 0.15, and 0.45. Now to compute the expected value, first I'm going to find x times p of x, so I'm going to label that. Then to answer that, I'm going to say this is basically the first cell, which is x, times the probability of that, and then I'm going to go to the cell that has the formula and populate my table. And for some reason this sheet isn't functioning properly, so I had to go to each one of these and double click on it and then click enter for it to work. Then the expected value or the mean is equal to the sum of the last column, which has the multiplication of x and p of x. So I'm going to find the sum for that column, and that will give me 4.1. So our mean is 4.1. The next question is asking to find the standard deviation. And again, we have a formula for the standard deviation as well. The first step is to find x minus mu, or the mean. We computed the mean in the previous step, so I'm going to just copy the first half of the table, or the first part of the table, and paste it over here so I don't have to do it again. The next step will be finding x minus the mean. So I'm going to say this cell is equal to x minus the mean, which is in my case 4.1. And then I'm going to populate and make sure that the formula is computing correctly by double clicking and then clicking enter. I'm going to double click on each cell and then click enter. Now that I computed everything correctly, the next step is to square the amount that I just created, all of these. So x minus mean squared. This means I'm going to take this cell and I'm going to raise it to the second power, and then I will populate my table, make sure to go to each cell and make sure the computation is correctly done. Now the last step is to multiply the last column by p of x, each value of them. So I'm going to say the last column is x minus mean all squared times p of x. This is just labeling. So this is equal to the last column times the probability, the corresponding probability. And then I'm going to populate, and because my sheet isn't functioning properly, I have to double click on each one and make sure the answers are computed correctly. Then if I add everything up, I'm going to get the variance, which is sigma square. So if I add everything together, the last column and the last column, I'm going to get the variance. So this number represents the variance. To find the standard deviation, I'm going to take the square root of the variance. So this is equal to SQRT of the variance, which is this number, and click enter. So the standard deviation is 1.8 in this case. I hope this video helped you understand how to find the expected value, the standard deviation, and how to find missing numbers from a probability table. And I will see you in a different one.